Okay, I've got to redeem myself for that crummy lesson that I taught on the Milkalope, that contextualized lesson that was awful and terrible and miserable. I've been schooled since that on the levels of learning for math by the researcher Sharma. And so I'm going to try again to teach a better lesson, or at least give you the outline of a lesson that I might teach about fractions using these levels of learning for math. So sorry again about the Milkalope. This one's going to be better. Okay, so first I'm going to start at the intuitive level. So I'm going to grab my phone here. Think about all those times where you needed to use your phone. You had an important call to make, or a text to send, or an email to send, or you wanted to watch that video of cats that somebody told you about. But you want to use your phone and you look and you see, oh man, you forgot to charge it last night and the battery power's down to nothing, or the battery power's down to a quarter and you're not sure exactly how long you're going to be able to last. So at the intuitive level, I'm trying to relate a concept to something that students already know, and students have definitely had the experience of wanting to use their phone and seeing that their battery life was down to a low level where they may not be able to use it. So that's starting off on a point where people know where we're talking about. So intuitive level, something where students already know. We'll move from the intuitive level now to the concrete level. And so concrete level, we could do a couple of different things. We could actually have people go around in class and look at their phones and see what their battery power is and try to describe to the person sitting next to them how much battery power they have left. Certainly a great thing to do on the concrete level is to use manipulatives. I could look and see maybe my phone, and I'm just using here using some algebra tiles that I'm going to use to talk about fractions. I can say here that my phone's at 3/4 battery life because I've got 3 green bars and just 1 red one. These are great tools, and especially algebra tiles are great for teaching algebra in a concrete way. But we could use other things. We could use fraction bars or fraction strips, both of which are extremely easy to make and use, and they really give a concrete some way we can actually put our hands on that math concept. It's tactile if we want to use the technical math term. But that really, when students can touch it and feel it with their own hands, it really makes that math concept come much more alive to them. So we've moved now from the intuitive to the concrete. And now, once we're feeling pretty good about things on the concrete level, we can move to the pictorial level. And so now maybe I can draw something or use this to show, here I've got a fraction that represents 0. I'm still here behind the paper. Or I could use this to represent 1/4 battery life. I could use this to represent 1/2 battery life. I could use this to represent 1 full battery life. And so again, I'm using pictures. I'm taking it from the concrete, where we use the manipulatives, to actually showing it in a picture, which is so easy, so much easier for students to understand. So once we've gone to the intuitive, once we've done that concrete, once we've done the pictorial, and students are still with us, of course, then and only then should we hit the abstract. As you were reading before, abstract is where a lot of math lessons start, and the teacher's on the board and we got the X's and the Y's rolling or whatever. But it's starting way down the line. We've missed those other levels that we need. So now once students own it at the concrete and the pictorial level, now we can get more abstract, and I can start using these symbols to represent things, the 1/4 being careful to draw the connection between this and what they learned before when they had the concrete or the pictorial, to show that 1/4 means 1 out of 4 parts of the circle, or you have 1 battery life green and 3 reds, showing that this means 1/4. So we've really drawn that connection, and then students can own that abstraction. Finally, we can move from there to application. And application is a higher level thinking skill that asks students to take what they've learned in one area and apply it in another one. So think a minute. Where else do we see fractions in real life. And I'm going to ask you to pause the video, and think a minute, where else do we see fractions in real life? So now that you've taken some time to think about where you see fractions in real life, I'm sure you've come up with some good ones. Cooking is always a very popular one that's used. The ever popular pizza, when we cut it up into 8 slices or what have you. Someone at a math workshop recently mentioned a gas gauge, which I thought is a great example of where we see a fraction all the time. And we see, we got 1/8 of a tank and we're trying to make it and we're trying to drive and we don't know whether we're going to make it, but we hope we're going to make it. And then the good feeling when we have enough money to fill up our tank and we know we can drive, we're pretty much wherever we want to go because we've got a full tank of gas. So those are some other ways. But if you can get students to take what they've learned in this one area, we've learned about the battery life from the cell phone, and if they can see that in other areas, the gas gauge, the recipe that we're trying to double or half or whatever, then they really understand that concept when they can apply it. Finally, last but not certainly least, we've got communication, and this is something that really is not done a lot in the math classroom. We want to try to look for ways where we can build in communication. So if a student can explain to you, or if they can explain to another student that math concept that you were teaching, we know they've got it. Because if they can explain it well enough to teach it, they own it. They've got it. They can do it. And so we should look for ways for our students could be teachers, whether they explain that with a partner, explain it in a small group, come up to the board and demonstrate that concept. Because as we see, teaching something in a lot of cases is the best way to learn something. And really, when we're communicating through the levels of math, that allows the student to put on the teacher hat, that teacher role, and be able to really learn that if they can teach it. So these are the levels of learning for math. And what I'm really hoping that we'll see through this is that if you're a math teacher yourself or spend some time, think about, where am I starting? Do I start my lessons at the intuitive level? And that's hard to do, I know. But can we at least start at the concrete level where students can actually touch something in their hands and use that as a jumping off place? So really think about, where am I starting as I teach a math lesson? And really work toward, what can I do to get myself on that, at least that concrete level, to begin there instead of starting way off in abstract land. Now, you're going to get a chance to apply what you've learned on the discussion board. You're going to get a chance to view 2 different math lessons that I found online. And using what you've learned about these levels, take a look at them. Think about, where do these lessons start? Are they starting concrete? Are they starting intuitive? Are they starting abstract? Where exactly are they starting? And I'll ask you to think about it. Think about this using those levels. What suggestions could you make to help make that lesson a better lesson, one that students are going to understand? Because a good math lesson, as good any lesson, is one that students can take, they can use, they can build on it for the future. Not just we've quote unquote covered the material, but have students really got that learning down so they can apply it and they can communicate that to somebody else. So I look forward to seeing your responses on the discussion board.